Hello and welcome to 3.3. We're going to be working with the converses today. So you guys may have been wondering when are we going to see these inverses, converses, contrapositives. I mentioned that we'll probably be working with converses but not the contrapositives and the inverses. Here are the solutions to 3.2 as always. If you guys have any questions, let me know. There are a few pages of answers, so make sure you check over all of them thoroughly. And here are the proofs. If you need help with the proofs, always ask me in class. This is the challenging part of geometry, is the proofs. So, and I'd be happy to go over them with you. They are tricky, but they just take practice. Okay, we're going to prove lines are parallel. So today, we are working with the converses. Converses from 3.2. So we're going to go backwards today. So we're going to prove lines are parallel. Before the lines were parallel. And things happened. We had a lot of congruent angles, or we had supplementary angles. Today, we must show the lines are parallel. That's our goal. So we're going to be working with the opposites, or the backwards. So again, we have a postulate right here. We're going to start with a freebie. Just like in 3.2, we get a freebie. If two lines are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel. So this says, if angle 2 is congruent to angle 6, then J is parallel to K. So it's backwards. So we don't know the lines are parallel until the corresponding angles are congruent. Okay, so it says, find the value of x that makes m parallel to n. So, in order for m to be parallel to n, these two angles, these corresponding angles, must be congruent. So 3x plus 5 must equal 65. I'm going to write over here, and that looks kind of hard to read. Okay, so I'm going to subtract 5, 3x equals 60. This is me showing my work. Divide by 3, and x equals 20. So if x is 20, the lines are going to be parallel because those angles will then be congruent. Now here we have our theorems. We have the alternate interior, alternate exterior, and the consecutive interior converses. So they're just the backwards versions of things from 3.2. So if 5 and 4 are congruent, then the lines are parallel. If 1 and 8 are congruent, then the lines are parallel. And if 3 and 5 are supplementary, then the lines are parallel. I'm going to do one of these proofs for you guys. Right here, we're going to prove the alternate interior converse. So if 4 and 5 are congruent, I have to show the lines are parallel. And again, the only one that I have right now to use is this freebie postulate. So if I can show the corresponding angles are congruent, then this postulate says the lines have to be parallel. Because that's the only thing that I have to go off of. So I need to show that 1 is congruent to 5. If I can do that, then the lines are parallel. So we're given that 4 is congruent to 5. And 1 is congruent to 4. Vertical angles. We're going to be using vertical angles a lot this year. Okay, vertical angles. Alright, so if 1 is congruent to 4 and 4 is congruent to 5, that means angle 1 is congruent to 5. And that same transitive property keeps showing up as well. So you may think that there's a lot of geometry. Well, there is, but there's some that are more important than others, such as vertical angles and transitive. Now, 1 and 5 are the same. Since 1 and 5 are the same, those are corresponding angles. That means the lines have to be parallel. So we can now say that G is parallel to H because the corresponding converse. And you need this word converse. This is the most important word here. Okay, now that we've proven the alternate interior angles, we can use this theorem to prove the other ones as well. So keep that in mind when you are doing the proofs in your homework tonight. And then these were some sample problems. Can you prove the lines are parallel, why or why not? This one's yes. Alternate exterior converse. And again, that word converse is important. This one's also yes. Corresponding, and this was a postulate, corresponding converse. Not that it matters. If you don't remember which one's a postulate, which one's a theorem, that's fine. And 1 and 2 mean 180. This one's no. It needs to be angle 1 is congruent to angle 2. Then it would be a yes. Okay, same side interior would be supplementary. Okay, paragraph proof. A paragraph proof is like a 2-column proof, except for you write a lot of words and you don't use 2 columns. So maybe not anything like a 2-column proof. It says R is parallel to S. So I'm going to mark that down. R is parallel to S. And 1 is congruent to 3. Okay, 1 is congruent to 3. Proof P and Q are the same. So what I want to do with this is show that, let's see, if I can show 2 and 3 are congruent, then that means I have alternate interior angles. So what I'm going to start out with is this. So since R is parallel to S, then that means 1 and 2 are the same. So 1 and 2 have to be the same because they're corresponding. And that would be from 3.2. Angle 1 is congruent to angle 2 because they are corresponding angles. Okay, so 1 and 2 are the same. It's given to us that 1 is congruent to 3. So we're just putting it in words. It's given to us that angle 3 is congruent to angle 1. Therefore, by the transitive property, two must be equal to 3, or congruent to 3. Because we have 1 congruent to 2, 1 congruent to 3, so 2 must be congruent to 3. Okay, since 2 is congruent to 3, that means that P must be parallel to Q by alternate interior converse. And there you go. So that's our paragraph proof. And again, you might think, how do I come up with all this on my own? It's one of those things that takes practice, and so like I said, you're gonna have a couple of homework questions tonight in here, and I'll show you which ones those are. These are your proofs right here, so just make sure you give those a try. Make sure you get help from me if you're not getting those. Before I end the video, I just want to talk quickly about this transitive property of parallel lines. This doesn't come up very often, but I just wanted to show this with you guys in case you see it. If two lines are parallel to the same line, then they have to be parallel to each other. So if P and Q are parallel, and Q and R are parallel, then that means P, it must be parallel to R. So I'm gonna leave it at that. Alright, that's all. Thank you guys for tuning in to 3.3.